All right, let's continue looking at integration with logarithms. So in the previous video, we looked at how we can use the log to integrate fractions often. So in this video, we're going to look at a couple things. We're going to start by looking at how we can use long division to help us with this logarithmic integration. And then we're also going to do some definite integrals. Okay, so we're going to start with the long division then. So first of all, let me give you kind of a rule here. Okay, so if we're trying to integrate a fraction and the degree of the numerator is greater than or equal to the degree of the denominator, then long division may make it easier to integrate. Okay, so let's go ahead and let's look at an example of this. Again, we're finding the indefinite integral. Okay, so let's say we want to integrate x squared plus x plus 1 all over the quantity x squared plus 1. Okay, so we're looking at a fraction where the degree of the numerator is the same as the degree of the denominator. So what we're going to do is we're going to use long division first to divide these two functions, and then after that we're going to try and integrate with that new function. Okay, so starting off with our long division. So we're going to divide our x squared plus x plus 1 by x squared plus 1. Okay, so remember with polynomial division, you just look at the first term in each of your two functions, and we think, what do we need to multiply an x squared by to get an x squared? Okay, and of course the answer is just 1. So we put a 1 up in our quotient, and then multiply the 1 by the whole divisor, x squared plus 1, which would just give us x squared plus 1, and then we subtract. All right, so if we subtract here, we would just get an x. Okay, all right, so there's nothing more to bring down. We can't put an x squared into an x, so we're done with our long division. So what we just found is that our x squared plus x plus 1 over x squared plus 1 is equal to the quotient of 1 plus the remainder over the divisor. Okay, so now when we integrate x squared plus x plus 1 over x squared plus 1, this is the same as integrating 1 plus x over x squared plus 1. And this is now going to be a much easier integral to deal with. All right, so let's go ahead and let's try and integrate that. So first, I'm just going to split this up as the integral of 1 times dx plus the integral of x over x squared plus 1 dx. I'm going to go ahead and just label these as 1 and 2 and handle them each separately. All right, so 1 is going to be easy. The integral of dx is just simply x plus c. That one's easy. second one can take a little bit more work, but it's also not too bad. So the integral of x over x squared plus 1 dx. All right, so this one we're looking at a fraction again, but now our numerator has a smaller degree than the denominator. So I'm going to use substitution, and I'm going to let u equal the whole denominator, x squared plus 1, which would make our du equal to 2x dx. All right, so let's go ahead and rewrite this guy then. So I'm going to rewrite this as 1 over the quantity x squared plus 1, and then bring the x out with the dx on the end. Now, of course, we need the 2 to make our du, so I'll balance it out with a 1/2 out front. And then if we make our substitution here, we'd have 1/2 times the integral of 1 over u du. This would become 1/2. Integral of 1 over u is the natural log of u, and always our plus c. And then plug that u back in. All right, so finally then putting it all together, we're looking for our 1 integral plus our 2 integral. So our final answer here, the integral of x squared plus x plus 1 over the quantity x squared plus 1 is equal to, so for this first one we found x plus c. I'll worry about the plus c on the end here. And then our second integral, we just found this logarithm. So 1/2 natural log of x squared plus 1. So that is our final answer. Now, the only thing that you could do if you wanted, take that 1/2 and bring it up as an exponent. You don't have to, but it kind of just cleans it up a little bit. And of course, a 1/2 as an exponent is just a square root. So that would be as far as we could take that answer. Okay, so that's it for our indefinite integrals. Let's move on to definite integrals. Let's just look at a few examples. Let's evaluate each integral. All right, let's say the integral from -1 to 1 of 1 over the quantity 2x plus 3. Okay, so I'm going to start by making a substitution. I'm going to let u equal the whole denominator, which would make our du equal to 2 dx. Now remember, when we're doing definite integration, we also need to substitute the limits. So our lower limit, 2 times -1 plus 3 would equal 1. And our upper limit, 2 times 1 plus 3 would equal 5. All right, so go ahead and rewrite this. I'm just going to keep it as x's for a second. All right, so for our du, we needed 2 dx. So I need to bring an extra 2 in here and balance it out front with a 1/2. And then make all of our substitutions. So now our limits are from 1 to 5, 1 over u du. Okay, so the integral of 1 over u, of course, is the natural log. And we're evaluating this from 1 to 5. And remember, with definite integrals, we don't need the plus c. Okay, so this would be 1/2 times the natural log of 5. minus 1/2 times the natural log of 1. Okay, now with the 1/2, I'm going to go ahead and just factor that out front first of all. And since 5 and 1 are both positive numbers, we don't need the absolute value bars. Okay, but with subtraction, remember that just is the same as division. So this is 1/2 times the natural log of 5 over 1, or 5. And then that 1/2 we can just bring up as an exponent. So this would be the natural log of the square root of 5. And if you wanted to plug that into a calculator to get a decimal, that would be about 0.8047. All right, let's do one more example with these definite integrals. Let's try the integral from e to e squared of 1 over x times the natural log of x dx. Okay, so we saw a problem similar to this in the previous video. So I'm not going to let my u equal the entire denominator, but simply the natural log of x in the denominator, which would make the du equal to 1 over x dx. All right, we'll change our limits as well. So our lower limit, the natural log of e, is just equal to 1. And then our upper limit, the natural log of e squared, is equal to 2. All right, rearrange this a little bit. So I'm just going to move the 1 over x out on the end with my dx, and then make the substitutions. So this is the integral from 1 to 2 of 1 over u du. All right, and of course, the integral of 1 over u is just the natural log of u. And then just plug those limits in. So the natural log of 2 minus the natural log of 1. Again, like we saw above, this is just the natural log of 2. And then if we plug that into the calculator, it's approximately 0.6931. All right, so that is it for our integration with logarithms.